Hey guys, Mr. King here. Today we are going to talk about ocean currents and climate. And we've talked about oceans and we've talked about what they're made of and we've talked about how temperature changes when you go down deep and there's more pressure. Today we're going to talk about how the oceans move. And when the oceans move, they carry with them different amounts of heat or cold. And when they do that, it changes the climate of different areas of the world. Now, obviously, you guys know at the equator, it's nice and warm because the sun's rays are most direct on the equator. So that water is going to be the warmest. But that water doesn't just sit on the equator. It actually moves in a variety of different ways. And that warmth that is from the equator, from all the sun, spreads out all around the earth. And so it takes some of that heat and distributes it all around into different countries and gives them nicer climates than they would have. So today that's what we'll be talking about. So first off, there's these things called surface currents, and you can see in the picture it shows the arrows of the water kind of circulating around. And you can imagine if you drew a line where the equator is, that would go right through the middle of the picture. And you can see that's kind of where the arrows all end up going. And so what happens is the warm water from the water at the equator circulates around and it goes towards either the North Pole or towards the South Pole, away from the equator. And as it goes away from the equator, it gets cooler. It loses its heat energy because it gets less sunlight and it has less energy, less kinetic energy, as we know with temperature. After it gets cold and it gets closer to the poles, it recirculates back toward the equator and it gets warm again. And that spinning of the water gives us those surface currents. And that's what allows the water to continually be rewarmed over and over and over again. So these surface currents is created by the wind that moves only the upper few hundred meters of seawater. So this isn't moving the water down below where we talked about the last time, where we talked about the thermocline or the deep water layer. This is just on the surface of the water. And it makes it move in such a way where instead of the middle of the earth being super hot with all the hot water, it kind of spreads it around. Now you guys have seen this one before, but probably what you don't realize is this is a real thing, okay? This is the Eastern Australian current, and this really exists. Now it's a little bit embellished or a little bit made up in the fact in the movie where they show it's like this giant river of water. It wouldn't actually look like that, but it does exist in the idea that it is a current or like a river of water inside the ocean. So check out what Nemo and Crush have to say here.
Hey, dude! Oh, what happened? Oh, I saw the whole thing, dude. First you were all like, whoa! And then we were like, whoa! And then you were like, whoa. What are you talking about? You, Minnie Man, taking on the jellies. You got serious thrill issues, dude. Oh. Awesome. Oh, my stomach. Oh. Oh, man. Hey, no hurling on the shell, dude, okay? Just waxed it. So, Mr. Turtle. Whoa, dude. Mr. Turtle is my father. Name's Crush. Crush? Really? Okay, Crush. Listen, I need to get to the East Australian Current. EAC. Oh, dude. You're riding it, dude. Check it out.
So that shows it, and if we go back to where we talk about the map here, you can see in Australia there's that line showing the East Australian current there that is actually the movement of the water. So it's kind of like having a fast-moving river inside an ocean, and that happens because of the winds, and they travel in that direction. So the one that is most important to us is called the Gulf Stream, and it's by us, and it's 100 kilometers wide, And it's warm water flowing east across the North Atlantic Ocean. Now it's warm because the water comes up from the equator, where once again the sun's rays are most direct, so it's heating it up, and it moves that water up through the Atlantic Ocean. Now if you watch kind of where this arrow goes up toward Iceland. And these surface currents, they influence the climates, and warm currents keep northern climates mild. Now this is a picture of the capital of Iceland, and Iceland's pretty far north, so you would expect that it would be frozen for a large portion of the year. But because you have this Gulf Stream traveling up from the equator, and you can see this is kind of the path following that green arrow, it brings warm water. And if you guys can imagine, if you've ever put your hand over a warm pot of boiling water, the air above the warm water is warm. And then that warm air is able to blow on shore. And so the warm water helps keep the harbor ice free, but it also helps keep the climate a bit warmer. Now cold currents also prevent excessive summer warming. So if we go back to our picture of the currents here, I'm going to go back to the beginning here. If you look, when it comes back toward the equator, it's bringing cold water. And that cold water, once it gets back up to the equator and stays there for a little bit, it gets warmed back up. But the cold water helps prevent the areas around the equator from just being super hot all the time. So because the water moves, it kind of gives us the best of both worlds. It gives our northern countries a warm climate, because it helps to keep them, because our warm water travels up towards the poles. And for our countries that are by the equator, the cold currents give them a cool breeze and help to cool them down a little bit. So it works out perfect. If the water didn't move, our countries that are to the north and the south of the equator would be very cold. And our countries that were near the equator would be very warm, because the water would just sit there and be just boiling and gaining energy. And so by circulating around and moving in those currents, it helps to distribute that warmth and that cold, and it helps balance our earth. So another kind of current we get is called a density current. And we've talked about how cold water and warm water, they're different. Their molecules are different. It looks like when you look at them, cold water is much closer together and warm water is much more spread out. If you make water warm enough, it goes from a liquid to a gas. And obviously warm water is closer to becoming a gas, so it's more spread out. Cold water is more closer to becoming a solid, because if you make cold water cold enough, it becomes ice, which is a solid. So it's more dense, it's packed together. So what happens is you have this dense seawater, which would be cold water, sinks beneath the less dense seawater, which would be warm water. Or if we're talking about density involving salt, if you have water that has a bunch of salt in it, that makes it really dense. It makes it sink down towards the bottom of the ocean, where this water that has less salt is less dense, so it rises up. North of Iceland, a density current flows along the ocean floor and spreads into the Pacific and Indian Ocean. And once again, that's helping to spread out not only the temperature, but also the salinity in the solids that are dissolved. The warm Gulf Stream, like we talked about, that replaces this cold current. So once again, where there was cold water, there's now warm water. And that energy comes from the sun hitting on the equator. Density currents help regulate rainfall and temperatures. So once again, when we're talking about spreading around that heat from the equator and spreading it to the different areas around the poles and the northern and southern countries, we're also talking about regulating rainfall, because if you just had water heating up all the time and not moving, you would have a ton of evaporation, which you guys know from studying the water cycle would lead to a ton of condensation where it creates clouds, and then we'd have a ton of rain all the time. By moving it around, it kind of balances it out, so you don't get a ton of rain just in one area. So this is another look at kind of the way the water rotates throughout the earth. And you can see there's definitely some warm currents and definitely some cold currents. And as they circulate back toward the equator, that's where they get heated up again. and they continue to move because when you have different temperatures or different amounts of salinity, they have to mix with each other. They don't just stay in one place. So you get these different currents that help spread everything around, which results in a very good climate for many people. So as the water is moving, we have this thing called upwelling. And this is where a current brings deep cold water to the ocean surface. And you guys can imagine on the bottom of the ocean, there's a lot of nutrients. As everything that is solid would sink down to the bottom, we have currents that rise up towards the top. And this cold water that gets brought to the top also brings with it nutrients. And this is great for fishing because it brings all the nutrients and the stuff that the fish would like to eat up towards the top. And by stirring up the water, you make it so just not the bottom feeders get all the food. Most fish are swimming up in the upper layer because it's warmer up there. And so by bringing those nutrients, that makes for great fishing, which also helps to regulate the amount of organisms in the oceans and things like that. All right, guys, so if you think about how important it is that the ocean water moves, that's really key to the Earth being a place we can live. If our oceans did not mix because of different temperatures and different amounts of salt in them, the water would basically stand still. And that would create a ton of problems. We'd have tons of rain on the equator. And it would be very, very dry. The farther north or the farther south you go, the farther you get away from the equator, the less rain there would be because there would be less evaporation because there wouldn't be as much heat. And so by mixing it and moving it up, it allows that warm water to travel away from the equator and keep areas warmer. And then when it comes back to the equator, it's lost its heat energy, it's lost that kinetic energy, and it helps to cool down the areas by the equator. So everyone gets the best of both worlds. All right, guys, take a good look at the quiz. Have a wonderful evening, and I will see you guys all tomorrow in class.